Hello class, so this is for solving circuits, so part of our electricity and circuits unit. So we're going to start first, do a couple practice problems, both conceptually and mathematically. You should already have talked about loop and junction rules, but now we're going to be really trying to put them into practice. Alright, so we have this circuit here that has a 9-volt battery, a resistor 1 of 6 ohms, a resistor 2 of 10 ohms, and a resistor 3 of 15. So at this point, I want you to pause the video and try to do this task. Rank the current from greatest to least. So even if you pause it and just take 15 seconds to kind of think about it, you will better remember it when we actually go through it. So again, pause the video, try it. Alright, so now that you've had a chance to try it, let's quickly talk about what we mean. So when we're talking about current, we know that we have some current. Current, remember, is I. We have some current leave the battery. That current, we can't ever have more current than we started with, and that current is also the current that will make it home again. So if that is our current, we can see that our current is going through R1, that same total current. So R1 will have the most current flow through it. And then R2 and 3 it's going to split. So by default, since we're splitting them, it's going to be less. And it will split unequally because we have unequal resistors. The 10 and the 15 will not take current equally. So when you're trying to figure out which current will be greater or less, think about, well, which path is easier to go down. Your little electrons will take the path of least resistance. So are more electrons going to go down 10 or the 15? Well, they're going to go down the 15 because, or excuse me, the 10, not the 15, because the 15 has more resistance. So they will try to go down the path of least resistance when they split. If they are in series, as is our R1, number 6, all of it. So if they're in series, they will get all of the current. If they're in parallel, your current will split unequally, and they will choose the path of least resistance. Alright, so the other thing they could ask you as far as ranking is rank or compare voltages from greatest to least. So if we're looking at voltage, one of the first thing, pause it, try it on your own, go. Alright, so now that you have paused the video, we now want to think about voltage. So for voltage, there is a split when there is series, but if they are in parallel, as these two are, they will always be equal. Always. If they are directly in parallel, your voltages for each will always be equal. And then something I really want to change about my notation. Sorry, it's me getting lazy. I should specify that it's the voltage of these and the current of these. So the trickier one is figuring out, well, which one gets more? R1 or both R2 and R3. And so this one actually is a little tricky for this as far as conceptual. They'll probably give you some hints if it was directly asking you this. But one thing you want to think about is, well, which one has a greater total resistance? And so for that, we want to do R equivalent to figure that out. So for R equivalent for this parallel is going to be 1 over 10 plus 1 over 15 because we are adding them in parallel. So that would be 3 over 30 plus 2 over 30, which will give us 5 over 30. Don't forget to flip it, get the reciprocal again, and we will get 6 ohms. So actually, they will be all equal. Because this whole section is 6 ohms, and this section is 6 ohms. So if they have equal resistance and equal total current, we'll have equal voltage. Alright, so now I'm going to prove it to you with math a little more in a second. Let me clear the air though. Alright, so I just redrew it again so I could erase all that junk. So now we actually want to solve a circuit. So if we're solving a circuit, the first thing I want you guys to do is to make at least a VIR, but probably, if there's any questions about power, make a full VIR P chart, or voltage, current, resistance, and power. And so you want to have a space for both every single resistor, and I'll try to color code this, each individual resistor, as well as a section for your total. And so normally you will always get your total of the battery. Alright, so the first thing you want to do is, if you can, find your R equivalent. That is the first step. And so I'm going to quickly find my R equivalent. I'm going to try to fit this on one page. We'll see how it goes. So to find R equivalent, remember you want to do the smallest piece first, or the furthest away from the battery. So that would be R10 and R15. So we're adding up R2 and R3. And they are in parallel, so remember when we do this, we're adding them as fractions. And we just did this, so I can do it really quickly again, but I'm not going to spend that much time because we did it on the previous page. So this is going to be 6. So we know that we have that R2 and 3 is equal to 6. And then these are in series, so we can really quickly, if we're unsure, redraw our circuit. And no, wait, this was a 6 ohm, this is a 6 ohm. That means they're in series, so we can just add them. 6 plus 6 is a total of 12. So our total resistance is 12 ohms. Alright, and then since it doesn't change the problem in any way, I'm going to actually make this 12 volts, or no, you know what, make this 24 volts, just so we can have nice even numbers. Hopefully you'll see what I mean in a second. Alright, so if that's 24 volts, now once we have we have 3, so when I say solve, if we have 2 out of 3, what it means is now use V equals IR. Only use it on the same row. So you cannot take anything from our total row and apply it up, or from any other row to any other row. So they have to be from the same row. So I'll better divide those. So if we have V equals IR, we know that we're going to have to divide our voltage by our resistance, which will get us a current of 2 amps. So here is now we start looking at our conceptual again. We need to understand how a circuit works. If 2 amps leave here, 2 amps go through that resistor. So that resistor gets 2 amps. Now we go back. We say, oh, we solved 2 out of our 3, V equals IR. So if we're solving for V, we're going to multiply 2 times 6, our resistance, and get 12 volts. Alright, so now we go back to thinking our conceptual. We used 12 volts here. We started with 24. 24 minus 12 volts is going to be, you guessed it, 12 volts. That means if our electron goes this way, it must lose or use all 12 volts, so that by the time it gets back, it used all 24 volts from our battery. Same thing if it went this way, it also used 12 volts. And that's why the voltage in parallel will always be the same. So these actually all use 12 volts. Oh, look, I have 2 out of 3 again. I'm now going to use my V equals IR, where I know my voltage and resistance. And for my students, I really, really am fine with you leaving them as fractions. Make your life better, easier, get good at fractions. Amps, please include your units. This would be 12 volts over 15, so 12 over 15 amps. Alright, so now we have power, and power normally is done at the end, depending on what kind of circuit and what information they give you, but power is just IV, and you can just solve that right at the end. Just multiply straight across, I times V. So 12 times 2 is 24 watts. 12 times 12 over 10 144 over 10 again, I leave it as a fraction, and then 144 over 15. And then same thing here, just multiply and you'll get 48 watts. The cool thing is if you do add these up, these will all add up to 48. If they don't, you know we made a calculation mistake and we will go back. Alright, again, we're going to do one more. It's a little long, so all of this will be cleared. And I'm going to go a little faster on the second time. It will take a little bit less time explaining. Alright, so we have a new and slightly more complicated circuit. So again, try them on your own. Rank your current, rank your voltage, and actually try to solve a full VIRP chart, and then just come back to this video if you want to either check your answers or get help along the way. You will learn better if you do it on your own. You cannot tell if you learned something until you can do it without help. Alright, that being said, let's get started. So again, pause your video, go. Alright, so as far as ranking the current goes, we know that we have a full current going through this resistor. So we know that the current through, I'm just going to leave them as numbers so I don't have to call them 1, 2, 3, 4. The current through the 8 ohm will be greatest because that's before any split. For example, if we had another resistor right here, they would get the exact same current as 8 because they're both in series with the battery. Alright, then we're going to have a split. This is going to have a 6 ohm resistance, and that's going to have 3, so the path of least resistance will absolutely be down to 3, which will be the side that they would go down, which will be greater than the current at 2, which will be equal than the current at 4. Even though they are on a different line, they are in series. If it hits 2, it's going to hit 4. They're going to have the same current. Alright, for ranking the voltage. The voltage is very split again. If they are in parallel, they will get the same voltage, but these things are in series again, so they're going to split their voltage there. Alright, in ways that your equation will help you, this one will also get the most voltage because the voltage at 8 has a higher current and a higher resistance, therefore it's going to have to take a higher voltage. Same thing with at 3, it's going to have a higher current, it's going to take more total voltage, because if the voltage at 3 is some number, the voltage of 2 plus the voltage of 4 should equal that same number, but they're not going to get. Therefore, none of these could be greater than any of the ones at 3. And I realize I just wrote current. Sorry about that. Alright, but these are not going to be equally split. The one with the larger resistance, it takes more energy, more voltage to get through. And so your final order will be like this. So this is probably more complicated than anything I would give you for a conceptual course, but it's there. Alright, I'm going to make room for solving the full VIRP chart. Alright, so I have my really nicely written VIRP chart. That was sarcastic, by the way. So, of course, fill in the things you know, fill in the resistors you know, fill in the total voltage, and now again, first step, find REQ. Alright, so to do that, we're going to start with our tiny series right here. So I'm going to just trash this circuit diagram. So we're going to start here. So if I add those, 2 plus 4 is, surprising or not, 6. So that would be our new and improved circuit. The next one we want to do is these. They are in parallel, so we're going to add them as fractions. So that would be 1 over 6 plus 2 over 6, which gives us 3 over 6. And then you do the reciprocal, which would give you 2. So therefore, this whole thing is just 2. This is 8. Therefore, our final circuit has just an equivalent resistance of 10 ohms. All right, I now have 2 out of a 3. So now we're going to use V equals IR. So that means our current is just going to be 1 amp. Now we're going to look for things that are connected directly to the battery. In this case, it is a series. So we know that that is going to have 1 amp because that's what our battery has. We now have 2 out of our 3. Our voltage is going to be 8 volts, which, as we determined in our conceptual, it should take the most voltage and the most current. So this makes sense. All right, from here, again, we want to work from the battery out. When we find equivalent resistance, we want to work furthest away from the battery back to the battery. So now we're going to go and start looking at this 3, because we know that if it goes, I'll use a different color, if it goes this way, it must use all 10 volts, and if it goes this way, it must use all 10 volts. It used up 8 volts right here. So that means going this way, it must use 2 volts so that we lose all 10 volts. So again, your conceptual helps you. Understanding how the battery works is very important. We now have 2 out of 3. We can just divide. So it's going to get a current of 2/3 going through it. And then for these ones, remember, they're going to get the same current, which is very helpful because we know we have 1 amp going through, and then it splits 2/3 one way. That means the other way must be 1/3, so that it adds up. And since they are in series, it'll be 1/3 for both. We have 2 out of 3. We can just multiply. So it's going to get 2/3 volts, and this is going to get 4/3 volts. And you can always check so that these should add up to the battery. So 2/3 plus 4/3 will get you 6/3, i.e. 2 volts, which is what we expected. So it'll add up to 8 to end up with 10. And then again, power is pretty simple after this. You just multiply your V and your I. For some of these, it'll be nice. For some of them, it'll not be so nice. And this, remember, is units of watts. Fractions are your friend. And if you're not sure, you can always check that all of this does indeed add up to 10 watts. So if we do want to check, we can. That'd be 6/9, i.e. 2/3, plus 4/3, which will get us 6/3, which will get us 2, plus 8 will get us our 10 that we wanted. Alright, hopefully this is helpful. Keep practicing with these. There are always more resources online if you need them, and I am always available for help. Have a good evening or morning if you're watching this late. Alright, so just check with yourself that do you know that if they're in series, their voltage will be divided normally unevenly, and in series, the current will be the same for both. If they're in parallel, their voltage will be the same for both, but their current will be divided unevenly based on the total resistance, or the V equals IR Ohm's law. So you should know how to solve VIRP charts using a circuit, these rules, and V equals IR, as well as finding equivalent resistance.